In our next module, we're going to talk about the zone-based policy firewall for iOS that is a replacement for the content-based access control that we previously talked about in the earlier modules. Now, the zone-based policy firewall, or the ZBPF, or simply the zone firewall, is essentially a modular quality of service, or an MQC-like syntax wrapper for the content-based access control, which we'll see is similar to the MQC that is used for QoS configurations, that uses the class map, policy map, and service policy in order to bind a particular firewall policy, in this case as opposed to a QoS policy, to a particular interface. Now, the idea behind the zone-based policy firewall is that it's going to make our configuration a little bit more modular than what we previously saw with the content-based access control, or the CBAC. But the key point to remember is that the zone-based firewall is essentially just referencing the CBAC inspections behind the scenes. So we have the same level of application support for things like HTTP specific inspections or SMTP for sendmail, except we're referencing this with a different syntax engine. Now, the main advantage of this, of using the zone firewall over the CBAC, is that it's going to give us some more granular controls over how the inspections actually occur between the interfaces. And the first way that it does this is by grouping interfaces together based on what we call their zone assignment, where the zone is going to be something like the outside zone or the inside zone or the DMZ zone, where maybe we would put our public web servers or our public mail servers. Now, what is different between the CBAC and the zone-based policy firewall is that the firewall filtering is going to be applied based on an association of the zones, which is known as the zone pairing. Now, with the CBAC firewall, we previously saw that when we wanted to do an inspection, let's say from the inside network to the outside network, we would apply the inspect command either outbound on the outside interface or inbound on the inside interface. And then based on the actual traffic flow in the data plane, that's going to control what goes into the inspection table or to the session table. Now, with the zone firewall, it gets a little bit easier to control exactly how the inspections work by defining these different pairings or the associations of the zones, where I could say that I want one policy that is applying for traffic as it moves from the inside to the outside zone, or from the outside zone to the DMZ zone. Now, the idea behind this is that if we decouple the interface and its actual zone assignment, it's going to make the maintenance of the policy a little bit easier for us to interface either from the command line or from the GUI interface like the SDM. So we'll see as we compare this to the CBAC when we actually get into the configuration. One thing that is nice about it is that it makes it very easy to add new interfaces to the policy. So if I have, let's say, two different ISPs, and it means that I have two different outside interfaces, we can treat those outside interfaces the same by simply assigning them to the same zone. So for any new interfaces that are applied into that zone, they're automatically going to inherit the policy that is applied to that zone pairing. Now, when we look at this in comparison to the previous CBAC configuration, if we have router 1 that has two different interfaces, it has an inside interface that is connected to our trusted network, and we have an outside interface that is going to the rest of the public network, this policy is going to be pretty easy to maintain regardless of whether we are using the CBAC syntax or the zone-based policy firewall. Where in a design like this, typically what we would want to do is watch traffic as it moves from the inside network and goes out. Then, depending on whether someone on the inside originated the session to begin with, we're then going to selectively allow that traffic back from the outside in. So very simple, stateful firewall design, just like we would see in the PICs or the ASA, or if we were doing something like reflexive access lists, or in this case, either the CBAC or the zone-based policy firewall. Now, for CBAC, we could then imply the inspection as the traffic is leaving the outside interface, so outside outbound, or as it is coming in on the inside. The end result is essentially going to be the same. Now, the disadvantage of using CBAC is that when we start to scale the policy, if we were to have not only an inside and an outside interface, but also an interface that is going to the DMZ and maybe a second outside interface that's going to another service provider, now it starts to be very difficult in order for us to define, well, what happens when traffic goes from the inside to outside 1 versus inside to outside 2. Or if we're coming from outside 1 and trying to go to the DMZ, or outside 2 to the DMZ. Because with CBAC, when we're actually applying the policy, it is applied directly to the interface. So we would have to have different applications, either as traffic is coming in on the inside, which means that this would affect traffic as it is going from inside to the DMZ, inside to outside 1, inside to outside 2. And we'll have some difficulties trying to maintain how do I actually categorize traffic that's going from the inside to the DMZ versus inside to outside or inside to outside 2. So this is typically where the zone-based policy firewall would want to be implemented. Because instead of applying the policy directly to the interface, we could group these 4 different links into 3 generic zones. Where for interfaces outside 1 and outside 2, we're going to group these together and say that these make up the outside zone. Then the inside likewise is going to make up the inside zone. DMZ likewise is going to make up the DMZ zone. So now when we define our actual policies that are going to be used for inspecting the traffic and determining what is going to go from the inside out and then return, I can do this explicitly by doing an inside to outside pairing. Then whatever actual policy that I apply to the inside to outside pairing, that is specifically going to control the traffic as it is coming from in to out or in to out to. Because since these 2 outside interfaces are in the same zone, it means that the same policy is going to be applied onto them. Then likewise, I could define 2 additional pairings, one that is going to be from the inside to the DMZ, one that is from the outside to the DMZ. So it's going to give me some more granular controls as to how the traffic is actually inspected when it is moving between these different interfaces. Now, additionally, later, if I add a second interface to the DMZ, we'll say this is DMZ2, as long as I assign this to the DMZ zone, I don't have to modify any of the pairings that I previously defined either for the inside to DMZ or the outside to DMZ. So again, the actual inspection behind the scenes is still done using the content-based access control engine. It's just that the zone-based policy firewall is a new syntax application or a new syntax wrapper that we're using on the CBAC that is going to allow us to make more granular changes to how the actual policy is applied. Now, in the zone-based policy firewall, there's 2 different types of zones that we're going to be dealing with. The first is the user-defined zones, the ones that we are creating that are going to control what is the outside zone, what is the inside zone, what is the DMZ, etc. So these names are going to be whatever descriptive names we want to create so that when we look at the result of the running configuration, we can kind of tell exactly what we're trying to do with that actual policy. So it probably wouldn't make sense to name the zones Zone 1, Zone 2, Zone 3, because then it's not very clear if I look at the Zone 1 to Zone 2 pairing exactly what I'm trying to do. But if I were to say this is the inside zone, this is the outside zone, when I look at the inside to outside pairing, it's a little bit more obvious exactly what I'm trying to do with this particular inspection policy. Now, the second type of zone, which is not available in CBAC, is what we call the self zone. And the self zone is going to control any traffic that is locally originated by the router or any traffic that is locally destined to the router, which would be if we were to log into the router's command line and do a ping on the interface, or we were to do a telnet from the router, or if we had any type of control plane session like an OSPF neighbor adjacency or a BGP peering session that's going to the router, that is going to be controlled by the self zone. Whereas previously when we looked at the content-based access control, we had to make some manual exceptions in order to allow the control plane protocols to be passed manually through the firewall. And typically the way that we would do this is by allowing in an access list manually in on the outside interfaces to say, I want to allow OSPF packets to come in, or I want to allow BGP and Telnet packets to come in. But with the zone-based firewall, it's going to be a little bit easier to maintain because we have this specific definition of the self zone that is going to control any of that locally originated or locally destined traffic. Now, as the filtering goes between these zones, if we have traffic that is intra-zone, or going from an interface that is in the same zone to an interface that is likewise in the same zone, for example, inside to inside, then this traffic is going to be allowed. So if I have two inside interfaces, we're not going to do any filtering between them. Likewise, if I had two outside interfaces. If I did want to apply an exception to this, I would have to apply an access list manually to the interface. The second type of filtering would be for traffic that is going between zones or interzone traffic. And by default, all of this traffic is going to be denied. So for example, traffic coming in an outside interface going to an inside interface, or vice versa. Any traffic coming in on the inside going to the outside, that is going to be denied by default. So in order to allow these traffic flows, we need to manually define the policy that is going to control what type of traffic is going to be inspected or what type of traffic is manually allowed as it is moving between those two different interfaces in separate zones. The third is going to be for any traffic that is going to or coming from the self zone. And the key point here is that this traffic is allowed by default. So it's automatically going to allow for any of our control plane sessions, like an OSPF adjacency on the outside interface. But we could potentially manually filter this if we were to define a zone pairing and apply a manual policy. So for example, if I define the outside to self pairing, and inside this pairing I call a policy that says I want to allow OSPF, I want to allow return telnet sessions, I want to allow return ICMP pings, but I want to drop other traffic, then this would potentially protect the router against any type of application attack or any type of denial of service attack against its own local interfaces. Now, to piece the zone-based policy firewall configuration together, it's going to be a three-step process that is similar to how the modular quality of service, or the MQC, works for our QoS configurations. And the first of these three steps would be to classify the traffic with a class map. Now, different than the modular quality of service, this is going to be a class map that is of type inspect. Or if I were to say class map XYZ, that's going to be referenced from the modular quality of service. If I say class map type inspect XYZ, that's specifically for the zone-based policy firewall. Now, just like in the MQC, we have two different logical matches for these, the match all and the match any, where if we were to say match all, and I have multiple match criteria inside of the class, all of those matches have to be true in order for the entire class to be true. So if I were to say I want to look at traffic from the host 1234, but I also want to look at TCP port 80, if I were to put those in a match all class, it would essentially mean any web sessions from that particular host 1234. If I were to say match any, we could use that, for example, for a class that is matching our peer-to-peer file sharing applications. Like we could say class map type inspect, match any file sharing that says match protocol BitTorrent, match protocol Kazaa, etc. Where in that case, as long as one of the matches is true, then the entire class is true. Now, unlike the modular quality of service, there's going to be two different types of inspection classes that we have with the zone-based policy firewall. And the first is known as a layer 3, layer 4 class map, where this is going to match any information, as you would expect, inside either the layer 3 header of the packet or the layer 4 header of the packet. And generally, there's going to be two different types of matches we do in here, either based on an access list, which would allow us to do matching based on source and destination address pairs, or to match on a protocol, which, similar to the network-based application recognition, or NBAR, inside the modular quality of service, this is going to be used to match the traffic based on its layer 4 header. Like if I were to say match protocol HTTP, then by default, this is going to look at for any flows that are TCP and they're using either the source port or destination port of 80. Now we can combine these together if we were calling them from a match all class, where I could say look at TCP port 23 from this particular host, 1234. So this then would be matching any telnet sessions that are coming from that particular host. The second type of inspection we have is a layer 7 class map, or the application level class map. This is what we use to perform what's known as the deep packet inspection, or the DPI. Now, DPI is going to be similar to the modular policy framework application level inspections that we saw previously on the ASA, where we're looking inside the individual layer 7 application. Like if it's a web session, we could look for the HTTP post message, or if it was a send mail packet with SMTP, we could say how many recipients are in the mail header. Then based on that particular match, we could perform application level actions. I could say if someone tries to upload a file from the web interface with HTTP post, I want to drop those sessions, or I want to reset them. Or if someone tries to send a mail with over 100 hosts in the to field, then I want to generate a syslog message, or I want to drop that packet. So just like on the ASA, the individual actions that you can perform are going to be based on what particular type of application you're dealing with. Where the syntax for a web inspection is going to be different from a voice over IP phone call with SIP, or for an SMTP or a POP3 or an IMAP inspection for mail traffic. Now, once the traffic is classified inside of the class map, just like in the modular quality of service, the next step would be to use a policy map to actually apply our action that we want onto the traffic. And just like where we have the class map of type inspect, we're going to use the policy map of type inspect. Additionally, just like the two different types of inspection classes we have two different types of inspection policies. Where the first one is a layer 3, layer 4 policy map that is going to be referencing the layer 3, layer 4 class map. We also have the layer 7 policy map, which likewise is going to be referencing a layer 7 class map. Where the first of these, the layer 3, layer 4 inspections, this is going to be used to do just a standard TCP-based application inspection, like match telnet, make sure that it's port 23 going out, and then it's source port 23 coming back in. Whereas the layer 7 policy map is going to look inside the actual application payload, and like I mentioned before, look at the HTTP post message, or maybe the specific URL that we're trying to reach, and we could do domain-based filtering based on the information that's inside the actual application header, or the application payload, I should say. Now, just like the modular quality of service, the policy map in zone-based policy firewall does end in a class default, and the class default will drop all traffic unless we have another more specific class that is defining what we want to do with it. So similar to an access list that is applied onto the interface, we're going to go top down and process our individual matches, but then if none of those match, we're going to fall back to the class default, which is going to have our implicit deny. Where typically with a firewall filtering policy, you would want to end in implicit deny, but you could technically change this around. If we were to edit the class default, I could say maybe from the inside to the DMZ, I want to apply some certain application inspections, but then for anything else that is not matched inside class default, I could simply forward this traffic. Now, inside these two different types of policy maps, the first of which, again, is the layer 3, layer 4 policy, we're going to have different types of actions that we can perform as compared to the layer 7 application policies. Where first and foremost, we have the inspect action, where this is similar to the content-based access control's stateful inspection, which is also similar to the ASA's modular policy framework inspection. Where the logic behind this is that if we are inspecting a packet, we're going to create an entry for the flow in a state table, Then if traffic is moving from the inside to the outside and we are inspecting it, when the traffic returns and tries to move from the outside back inside, we're going to check the state table to see if that traffic flow should be allowed. So in the vast majority of policies here, we would be inspecting traffic as it goes from inside out. And then the outside back in traffic is automatically going to be allowed based on the state table. Now again, since in the class default, we automatically are going to deny any traffic that is not previously matched, it means that if we inspect the flows that we want, then all other flows would be automatically denied. The next action we have is the pass action, which is a one-way manual exception. Now, this is different than inspect, where inspect says if I go from inside to outside and inspect, it means that I'm going to automatically allow that flow to return from the outside back in. But with the pass action, this would be essentially the same as putting an access list on the interface and then having an explicit permit for whatever that flow is in a one-way direction. So what this implies is that if traffic is passed from the inside to the outside, it does not automatically pass it from the outside back inside. Now we'll see when we actually look at the implementation of this, the reason that you may want to pass traffic as opposed to inspecting it is if the flow is some sort of non-standard application that the firewall, or the CBAC engine more specifically, doesn't actually have an inspection engine for. And one of the things we'll see, like we previously saw in the CBAC, is if we're trying to do a trace route through the zone-based firewall. So for anything where the outbound flow is different than the return flow, like a trace route or maybe an active FTP session, and then we can make manual exceptions for this with the pass action. But again, the key thing to note here is that this is a one-way exception. If I pass the traffic from inside to out, doesn't necessarily mean that it is passed from the outside back in. Next action we have is to simply drop the packet, which is going to discard it, similar to an access list manual deny. Next one we have is to log the packets, which is going to generate a syslog message that we could either send to the console, send it to the buffer, or actually send it to a remote syslog server. We could police the traffic, which is similar to the modular quality of service police action, which is going to be used to rate limit the traffic to a specified value. So if I were to say I want to limit the FTP traffic as it goes out, I could police this to a rate of 1 million bits per second. So this means that my outbound FTP flows would be limited to 1 megabit per second. Then lastly, we have the service policy action, which would be to call a layer 7 policy map for the deep packet inspection. So we'll see that the final logic of the zone-based policy firewall's syntax is similar to the modular policy framework in the ASA, where a layer 7 inspection policy is going to be referencing a layer 7 inspection class. Then that layer 7 policy is going to be called from a layer 3, layer 4 policy, which then in turn is referencing a layer 3, layer 4 class. So when you're actually doing the implementation of this, you need to be very clear about how the syntax pieces together, because otherwise it can be very confusing to see that one class is pointing at one policy, which points back at another class, which points at a different policy, etc. So when we look at the configuration of this, we're going to break it down into its small modular sections. We'll look at the basic layer 3, layer 4 policies first. Then we'll look at the application-specific inspections. Now, the application-specific inspections, these are going to have some different application actions depending on what is the actual engine that we're using for the inspection. So the key is that different protocols are going to support different actions. Where web inspections would allow you to reset the packet or to log the packet or to allow the packet, that's not necessarily going to be true of a voice over IP session or a mail type inspection. But in general, there's going to be 3 actions overall. First one is that we would allow the flow. So we're simply going to allow the session through, which could then forward it to our normal layer 3, layer 4 policy inspection. The next action would be to reset the session, which is only going to be used for TCP sessions, which means that we are sending the TCP reset or the RST in order to terminate the session. So I could say, for example, that if someone tries to do web browsing to youtube.com, then I want to reset the session, so they're not allowed to do that. And our third action here would be to log the traffic. So just like in the layer 3, layer 4 policy, I could say if someone tries to get to this URL that I'm trying to filter, I want to reset the packet, but I also want to generate a log message. So I can see if any of the users are trying to get around the firewall filtering policy.